All right, welcome to the last module of Algebra 2. We are almost done. Also, welcome to your last assignment of Delta Math. So, Module 10 is all about the matrix. So, if you've ever seen the movie, I have not. It's not about that kind of a matrix. But we are going to talk about basic matrix operations today, and then the next class we'll talk about solving a system with matrices. So, a matrix, if you look up the definition, it is a surrounding or a structure. And so in math, a matrix is these little brackets. And so that's what a matrix is for Algebra 2. So today, we're going to add them, subtract them, and multiply them. We're going to multiply by scalars. We're going to figure out if a product of matrices is defined, and then we're going to solve some real-world problems. So first off, a matrix is a rectangular array of numbers, and the dimensions of a matrix are going to have rows m and columns n, and it is read like this. It is read m by n. So like many of you guys have seen a 2x4. It's like a 2 and then an x and then a 4. So the multiplication kind of means by. Where they get these numbers from. In this picture right here, the rows are going to go up and down. Sorry, I lied. The rows are going across, and then your columns are going up and down. So this has 2 rows and 3 columns, hence it would be a 2 by 3. So you count your rows first, and then your columns. And I will teach you a shortcut to remember that. All of the numbers in the matrix are called elements. And 2 matrices are going to be equal when their dimensions are the same. And we'll talk about that in a problem. So, how to remember row versus column. Column, I think of ancient Rome, and a column is going up and down. Front row, like if you're a front row at a concert, you are going to be down here. So think left to right for row, and then think up and down for column. Now the way I remember you do the rows first is I always heard the saying, first get your ducks in a row. So when you do matrices, the first thing you start with is the row. So let's do some problems. So we're going to add and subtract them first. And so you can add or subtract matrices only when they are going to have the same dimensions. So if you've got a 2 by 2, like this example, we've got 2 rows and 2 columns, and then I've got 2 rows and 2 columns. I am allowed to add them, and you will get the same dimension. So what you would do is you would take the top left and the top left and add them. You would take the top right and the top right and add them. Same thing for subtracting. So if you guys want to get highlighters to kind of color code today, feel free to do that. But let's do some problems. Also, a zero matrix is a matrix where 0 is everywhere. So we're actually going to talk about the zero matrix in this problem. Example 1. Perform the indicated operation if possible. If not possible, explain why. So in part A, I've got a 2 by 2 matrix, and I'm going to add the zero matrix in. So I would take the top 2 numbers, 2 plus 0. And then 2 plus 0 is 2, and that's the top right number. Then you would move to the top left number, or right number, sorry. -1 plus a 0 is going to be -1. So if you're adding a zero matrix, it's going to be the same matrix. On the next problem, I have a 3 by 2 matrix. I have to check myself because I get stuck on those. And then you have a 3 by 2 matrix. So you are allowed to add or subtract these two. So start with the top left. You are going to have 2 minus a -1. And if you want to write that out to help you, or you can just type in the calculator, or we can know 2 minus a -1, you're actually going to add those. So 2 plus 1 would be a 3. So the top left number of your matrix would be a 3. The next problem, we've got -3 minus a 2. And so again, if you want to write that to help you out, because this would be on a non-calculator portion to do some mental math. -3 minus a 2, they're both negative, add them to get -5. Moving on to our middle row, you've got 5 minus 7. And so that's what you would write. And we know 5 minus 7 is -2. So if you don't need to do this step of showing your work, you don't have to. But if it helps you do your mental math, go for it. Next one would be 4 minus 8, which we know is -4. And the last two rows, bottom left one is a little tricky because you've got minus a negative. But just know if you've got minus a negative, that's going to turn into a plus. So this essentially is 5 minus 2, which would give you a 3. Okay, so subtracting a little bit harder than adding. On part C, I have a 2 by 3 matrix, and then I have a 2 by 2 matrix. So I can actually not add these because nothing quite matches up perfectly. So it's called undefined. You are not able to add that matrix at all. So that is adding matrices. Let me know if you have any questions. But we are going to move on to distributing. So a scalar multiplication is very similar to distributing. When you're going to multiply a matrix by a scalar, you're going to multiply every single element or number in the matrix by that number. So for example, if you had the letters A, B, C, D, and you were multiplying them by K, you would have Ka multiplied, Kb multiplied, etc. So on this example 2, perform the indicated operation, you are going to multiply 2 by every single thing in there. So you would have 2 times 3, and then 2 times -2. So your top answers would be 6 and -4. You would multiply your middle numbers to get 2 and 10, and then you would multiply to the bottom numbers to get 4 and 0. And that is it. Now they can add up a level of difficulty by, adding and multiplying. So first you're going to need to distribute this -3 to just this matrix because it's not in front of the other matrix. And then once you get an answer to this one, then you will add it to the second matrix. So -3 times 5, I'm going to show my work, -3 times 0, -3 times -2, -3 times 4. If you don't need to show that step, you do not have to. But we would get -15, a 0, a +6, and then -12. Now I'm going to take this answer and add it to your other matrix. Now when you're adding, 15 plus a -1 would give you -16, 0 plus 7, 7, 6 plus 3, 9, and then -12 plus a 2 would be a -10. So just know that all of this would be on a non-calculator portion of your test because we can do mental math. All right, we are going to move on to multiplying. Now, multiplying matrices is the most difficult, and we're not going to get to dividing, so there's a good thing. So we're going to start off with, first off, figuring out if you're allowed to multiply the matrices, and then you will watch part 2 on actually multiplying the matrices. So when you're multiplying, the product of two matrices is defined, meaning you can multiply it, if the number of columns in A equals the number of rows in B. So what that means is if you have some matrix A times some matrix B, it has dimensions, let's say m by n, and then matrix B has to have some dimension n by p. If these two numbers are equal, that is the only time you're allowed to multiply the matrix. If that is true, they kind of cancel out, and your answer results in the M by P matrix. So for example, let's say I have a 3 by 2 matrix, and then I want to multiply it by another 3 by 2 matrix. Because these numbers do not match up, you cannot do it. You're not allowed to multiply it. Now, let's say you have a 1 by 5 matrix, and then you have a 5 by 2 matrix. Since these numbers match up, you are allowed to multiply, and then your answer would be a 1 by 2 matrix. So that's kind of how you figure out if you are allowed to multiply a matrix. Now, could you add a 3 by 2 and a 3 by 2? Yes. You can add them and get another 3 by 2. But when you're multiplying, these numbers have to be the same. Okay? So, let's try some problems with that. Example 4, determine whether the product of AB is defined. If so, state the dimensions of AB. So A, think about your rows first. So I have a 2 row by 3 column. So that is a 2 by 3 matrix. B over here would be 1, 2, 3 rows by 1, 2, 3, 4 columns. Okay, so since these match up, I am allowed to multiply these two matrices. So they would cancel out, leaving you with an answer of a 2 by 4 matrix. So because the number of columns in A equaled the number of rows in B, your matrix is defined. And the resulting matrix would be a 2 by 4. Okay. Now, if we flipped this around, we would not be able to do B times A. Because if I flipped these, the 4 and the 2 don't match up. So the order is super important when you are multiplying matrices. Let's look at the next one. I have a 2 by 3 matrix, and then I have a 2 by 3 matrix. So can I multiply these? No, because these two numbers are not matching up. So even if you wanted to multiply them, you couldn't. It's impossible. It is not defined. Okay. Now if you flip-flopped them, you could multiply them. But we cannot figure out the product AB. You could figure out the product BA. And we're going to pause there. So thanks for watching part 1 on basic operations of matrices. You're going to go ahead and head to part 2, where we're going to talk about multiplying, and then I'm going to teach you a shortcut to do everything in the calculator, which is so fun.